going to move from nanoscale to industrial scale or full scale, because obviously after one experience, we're an expert. I'm going to talk about bringing the technology from lab scale to a large scale application. So as my colleagues already mentioned, we're dealing with a variety of complex water challenges. Some that stem from, for example, overpopulation or climate change, like water scarcity, but also others like the new occurrence of PMTs, like Jing mentioned, that affect the water quality. But also deteriorating infrastructure, the water-energy nexus, which is a relationship between the water that is needed to basically produce renewable energy or energy in general, and the energy that is needed to produce water for these processes, but also for the wastewater treatment and drinking water treatment. And as a final one, circularity, we have to recycle more water and see how we actually, where we give a place of this recycled water in our society. And to answer all of these challenges, well, the solution is science and technology development or research, and that will give us the tools to meet these challenges. The path that the technology goes through in its development is actually indicated with a level of TRL, or technology readiness level. This is a scale that has been introduced by NASA, the National Space Agency in the US. And they use these TRL levels to indicate the development or the readiness level of a technology, going from TRL 1, which is basically an idea, basic technology research, to all the way to TRL 9, which is the system test, launch, and implementation in society. So our technology that we have presented here already today has already gone through a couple of these steps and is going through several other steps. And it all started with an idea, the idea to bring concepts from the battery industry and incorporate them in or use them in electrochemical water treatment. So we took an idea of they're using graphene. Well, we came out with our graphene sponge electrodes, or graphene-enabled electrodes, and well, which led us to TRL 3, more or less. We validated this technology in the lab, first with this lab-scale reactor, but then we are now actually in the process of scaling up this technology. So we built a full-scale reactor, or an industrial-scale reactor, which is actually modular and that can then be replicated into a stack to treat higher volumes. And where we want to treat is actually, where we want to reach, sorry, is actually a fully integrated technology, which means that our technology will be coupled with other technologies to fulfill the full treatment train. Obviously, the road on technology development is riddled with all objectives and other challenges, like, for example, scalability to increase productivity, the efficiency, whether or not it has long-term durability, sustainability, robustness, and the equipment that is needed, not only lab scale, but also at a bigger scale. So we encountered a few of these challenges. For example, when you applied our sponge in more realistic waters, or moved away from a very controlled lab-scale environment, well, we had some peculiar behavior. Also, we had to rethink the lab-scale reactor that we were using, because this could not be applied at a larger scale, so we had to rethink the design. And basically, what we want to do with this scale-up is kind of like de-risk the technology, to lower the uncertainty and to convince early technology adopters, which are industry clients, people who are ready to adapt a new technology and give it a try. The problem is that the resources available for this development aren't always the same along the whole path. So at the beginning, as we see at the invention, there's a lot of resources available through grants from the government, European grants, to fund this academic and lab research. And after the further development, once the technology is already proven, well, then there are private investors, the private sector investments, and just sales activities that give you, again, resources to further develop or further scale up the technology. However, there's a problem because in between we have a little bit of a gap, and which is called the valley of death. That is why a lot of technologies basically don't make it out of the lab or die in the lab and don't make it to society. So what we have to do is basically cross cross this valley of death. And for that, we could basically use a survival pack. We can think of also when you're going on a trip, well, basically what you take to keep going is water. So basically you have to think about diversifying your funding to keep going to, and there's a lot of availability. Actually, there's a lot of there's a lot of grants that are basically helping to transfer this valley of death. Like, for example, Knowledge of Industry, which is a Catalan grant, which we also applied for, which has different modalities to help you in the different stages of this development, but there's also European grants, etc. What you also take is tools, maybe a flashlight, a rope, a compass to guide you. So basically tools to where you actually de-risk your travel, your path. Obviously, radio for partnerships or communication, which is very important. Also, communication with the Technology Transfer Office. INICRA is very important because they can help you with the further development or guide you. And obviously, before you set out on a hike, well, you know your body, you know your limits, you know your limitations, and you know, hopefully, which path you're going to take. So the same is true with the technology. Know your strengths of the technology and play into it, into the reality. So know where it can be applied easily and go for this, let's say, low-hanging fruit. Validate your technology there and then expand to other territories. So my message would be, don't let your technology die in the lab, because it's already an impact in the lab, but if you ever want to have a real impact, that actually starts beyond the research bench. So thank you.